In this video, we are talking about the Pythagorean theorem and just going over a refresher course on that. So for any right triangle, now a right triangle means that you have a 90-degree angle in one of those angles. So I've got this one marked so that it forms a right angle in the bottom left corner. That makes this a right triangle, only if you see that marking, or if you see that it's marked as 90 degrees. Now, the side that is directly across from that 90-degree angle is your longest side. So C is the longest side of this triangle. Well, if I have a grid, or if I'm told the length of this side, A, or this side, B, then I can find the length of C. So notice how on this grid, I could simply count how tall this is by counting how many squares it is on the grid. But we can't do that when we're going diagonally, because going through from corner to corner on each square on the grid, they're not all a single whole number length. So what we have to do is use the Pythagorean theorem. Now, the Pythagorean theorem tells us that if you have a right triangle, a squared plus b squared is equal to c squared. That's only if you have a right angle. So let's look at some examples. I'm going to pull up Desmos for this, because we're going to be dealing with some squares, and we want to make sure that we are being accurate with those. So in example 1, I have this right triangle. I know that it's a right triangle because it has this marking. I'm told that what we would call A is 9, what we would call B is 6. So if I have a squared plus b squared equals c squared, I can just plug those in. So a is 9 and b is 6. Now I can solve this equation to solve for c. So 9 squared is 81, 6 squared is 36, and we don't know what c squared is yet. But what we can do is add those up. So 81 plus 36 is 117. Then, to get c by itself, we can take the square root on both sides. So to undo this exponent of 2, I need to take the root, the square root. So the square root of 117 equals c. So you can think of square roots and squares. They cancel each other out, and you're just left with the c. If we wanted to approximate that, the square root of 117 is about 10.8. Not exactly, but it's close. Those little squiggle lines mean approximately. All right, in example 2, notice that in this one, we don't have those numbers given to us, but what we can do is we can use the grid to count them out. So if I use my grid, I can see that this top side is 1, 2, 3, 4, 5, 6. The left side is 1, 2, 3, 4, 5, 6 as well. And then I don't know this side. The reason I don't know that side is because it's diagonal on the grid. If you're ever unsure of which side you're looking for, it's always directly across from the right angle. All right, so we have our two lengths, so we're going to do 6 squared plus 6 squared equals what squared? So we're going to call that c squared. Right, so 6 squared is 36. Then we can add those together. 36 plus 36 is 72. And then we can take the square root on both sides. So the square root of 72 equals c. So just to approximate that, the square root of 72 is about 8.5. Okay, and finally in example 3, we have a grid here. We want to know what is the diagonal length, and we can find that because this is a right triangle, so we can count out how long each side is. So this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this side on the right is 1, 2, 3, 4, 6, 7, 8. Right, so we're doing 10 squared plus 8 squared. It doesn't matter which order you write them. I could do 8 squared plus 10 squared. All right, so 8 squared is 64. 10 squared is 100. So that's 164 equals c squared. And we're going to take the square root on both sides. So that's the square root of 164 equals c. To approximate that, the square root of 164 is about 12.8, excuse me. That's just a quick review of the Pythagorean Theorem, and in case you weren't aware as we've been going along, anytime you have something squared, 10 squared, that means 10 times 10. 8 squared means 8 times 8. I'm pretty sure you were aware of that, but just wanted to remind you in case you had forgotten.